Um, Great. Um, so as you can see on the screen, this is our agenda. We've got two great presenters here that'll be the first half of our meeting. One is Spencer Egan from RLC Engineering, and RLC has been helpful in throughout this process. Um, Doing some the engineering work and the analysis of the circuits and the things that have gone and the power outages that have happened. So Spencer's here is going to give us some core understanding about the spectrum between sort of plain vanilla backup all the way up to microgrids. And then Kelly Kaufman's here from Revision, and most of you must know Revision Energy. And Kelly is particularly focused on the PV and storage, the solar and solar storage solutions. And so Kelly's going to walk us through some use cases and what that can look like and what it might look like for Maine and Southern Maine. We'll do a half hour of those two presentations, and then we'll use the other half hour to have a conversation with Kelly and Spencer and Karina and whoever else. So that's our agenda. I thought it might be nice before we jump in. We don't know who you all are. And although many names are familiar here, and we could use the chat to just tell your affiliation. That would be really helpful so we know who's in the room. Um, and so go ahead and drop in the chat. Like for instance, I'll be uh, just typing in my affiliation here, the Consensus Building Institute. And it's nice to meet those of you who don't know me. Um, so go ahead and do that. It'll be interesting to see who we have here. We have a nice turnout today for the conversation. Okay, with that, Karina, why don't you drop your screen and I'll turn it over to Spencer, who has some slides. And Spencer, let's take a 10, 15 minutes and walk through your presentation. We can do some clarifying questions if we have some, but I want to save most of the discussion for after Kelly's presentation as well. So Spencer, over to you, and the floor is yours.
Great. Thanks, David. My name is Spencer Egan. I'm a power system engineer here at RLC Engineering. We are an engineering consulting firm with 3 locations in Maine, but we serve clients all across New England and all across the country. We serve both developers of generator units from small distributed generation all the way up to large sort of transmission scale developments, and we also serve utilities across the nation. All right, let's see if I can. Okay, so a microgrid is a pretty broad concept, but at its core, the Department of Energy and the Department of Defense define a microgrid as a system of loads and one or more generators that can operate in a mode both connected with sort of the macro grid or the bulk electric system, or independently, sort of in an islanded configuration. And so that, like I said, it's a pretty broad concept, and sort of the scale and complexity and cost can vary pretty greatly between things that sort of still fit under the umbrella of a microgrid. So on one end, we might have residential solar with battery backup. That's something that Kelly will speak to next. And on the other end, you might have an island distribution system. Think about some of the inhabited islands here in Maine, with a connection back to the subtransmission network on the mainland. And with that comes sort of all of the systems that are required to operate an electric grid, very similar to like what CMP and Versant have. So when thinking about a microgrid, I think it's probably helpful to think about sort of what the objectives are, because again, a microgrid, it can sort of do many different things, several at once, and so it means different things to different people. And then what are the required like technological components that are necessary to fulfill that objective? So sort of in a most sort of limited use case, you have what I'm calling limited backup, which may be, 4, 8 hours of backup for things like, perhaps the boiler in a building, refrigerators, things like that. And so in that case, you might have what we call sort of a critical loads, which are loads that you want to keep energized for that sort of planned duration. And those are sort of separated out from the rest of the building. So you're limiting the total amount of energy that's required to supply those loads with power in an outage. Um, but and whereas the rest of the building isn't going to sort of remain energized, and so you can fulfill that with several different solutions, but probably the most common one these days is solar plus batteries. So that fits in our sort of microgrid definition as the solar. It's a generator. It's supplying power in a grid connected mode, and when there's an outage, it can operate independently and supply power to those critical loads. One layer down in sort of, or one layer up, I guess, perhaps in complexity and in cost is something that's a little bit more resilient. So in Maine, a lot of our power outages can come in the winter. And during the winter, you might not have as much sun. Well, you definitely aren't going to have as much sun. It's lower in the sky. It's up for a few hours in the day. And you might have snow and ice that's covering your modules. And so you might not be able to recharge the storage system in the event of a prolonged outage that lasts for more than that 4, 6, 8 hours. That sort of is the core of a limited backup application. And so for that, you might want to have a generator that can also charge the storage system as well as the PV. Still a microgrid. That generator might not run when you're connected to the grid. In fact, it almost certainly won't for sort of small commercial applications. But the system as a whole still is connected to the grid and can operate independently. Another layer of complexity is things like interactive loads. So with interactive loads, you might want to be able to control, HVAC systems dependent on sort of conditions with the microgrid. Fleet charging is another sort of obvious use case here. And those interactive loads, they're participating in the microgrid system, both in a grid connected mode and in an islanded mode. In a grid connected mode, you might want to control those loads in order to limit your demand related costs when connected to the utility. And in an islanded mode, you want to control those loads in order to make sure you're not depleting your storage too fast, or sort of limit the total amount of energy you're using in that sort of islanded mode. Um, another objective that you might want to have, or another use case, is something like seamless campus backup. And so by that I mean it's a collection of buildings. Think of like something like a college campus, where those buildings are connected by medium voltage conductors. So that's like kind of like the voltage you have out on the street. They're not they're not they're not fed from a single panel board or a single switchboard inside one building. And so you have varying voltages amongst the system. Maybe you have multiple different PV systems on the different facilities, and you want to be able to operate that sort of more complex network of generators, and perhaps you have multiple storage assets as well, in a way to provide power to the entire campus. And in that application, typically you have one, maybe two connections with sort of the macrogrid, with the CMP or the Versant system. And in this application, you end up needing more sophisticated controls and sophisticated protective devices because you're working at those higher voltages. The equipment is generally more expensive, so it's worth it to pay more money for sort of more advanced protective devices. There's more regulation involved with how you connect and disconnect, how you're operating your network, your system when you're in that grid connected mode. And so you pretty quickly start having to add on a lot more hardware and a lot more sort of customized engineering and controls development for your specific application because it's not like you'll be able to have sort of a turnkey system that you can sort of pull off the shelf like you might for a residential setting or a small commercial building. Um, and then sort of the most complex is kind of like what I mentioned on that first slide, which is an islanded power system where you have a full distribution grid to control. You're connected to directly to the subtransmission system, and in that case, you have even more equipment, more protective devices that are necessary, and more study work and engineering time required up front to develop a solution that will keep the system sort of in a safe operating state, both grid connected and when you're in an islanded condition. In those last two use cases, having those different voltage levels means that you also have transformers in the system, and you might also have much larger loads, things like large motors and things like that. And motors and transformers are two types of loads or two types of equipment that are especially challenging in the design of a microgrid because basically they have a much larger power requirement. And we can get into it in a sec, but there's sort of, you can think of your energy requirements and your power requirements, and transformers and motors have larger power requirements that may affect the complexity and the cost of your microgrid solution. So I'm putting this graphic in, and don't take it too literally. It's sort of just trying to convey sort of the rising complexity and cost between all of those different types of solutions and objectives. And I think what's important to keep in mind is this is not a straight line, meaning that sort of the with every sort of layer of complexity that you add, or with every sort of use case that you add, the complexity and the costs rises faster and faster. And again, that really comes down to whether you're sort of needing a more off-the-shelf solution where the hardware and all the protection and controls are sort of all self-contained, it's pre-engineered, or if you need sort of a customized solution where you're building things up from scratch, you need more studies up front to determine, what the appropriate level of protection or what type of control logic might be required. Um, the complexity of the system can grow quite rapidly as you build out in scale and capability. And so, this is just showing some of the solutions and the objectives that we discussed on the last slide. So, thinking about what drives that complexity and really what drives the cost of a system, which is probably going to be on the forefront of the mind of anybody that's thinking about installing something like a microgrid. Your two biggest drivers to keep in mind are energy requirements and power requirements. So energy requirements is a function of the total kilowatt hours of usage that you intend to use during an outage, or the total amount of energy that you might want to offset when in a grid connected state. So let's say you are trying to limit your demand charges or trying to limit your capacity tag requirements. Um, the energy is the energy over the entire period of that you're designing around, the entire dispatch period. Um, Power is sort of the instantaneous usage, and that's a function of kilowatts. So that might reflect your demand charge. But when you're designing a microgrid, you don't care just about sort of the 15-minute demand that CMP and Versant bill for, but you also you need to concern yourself with smaller time scales. So what's your 1 minute power usage, your 1 second power usage, or even sort of sub-second power usage during during events like when you're first connecting a transformer or when you're starting up a motor and things like that. Um, Unlike when you're connected to the grid, there is sort of a finite amount of power that your microgrid resources are able to deliver, especially with inverters and other so like PV inverters or battery inverters. They are power and current limited on those sort of very short time scales. So that's something to consider. Um, the geographic spread of equipment, the more, if you have several facilities, that requires communication between all those devices. It means that each device probably isn't coming from the same vendor, and so you have to integrate the different devices. And then the other thing is sort of the number of devices that require some form of control logic. And again, as your application gets more and more specialized and unique, that's going to require more customized programming of that control logic. And so that's going to be another sort of really large cost driver that might not that you might not see sort of if you're just looking at sort of price trends for batteries in terms of dollar per kilowatt hour. So a couple key considerations, thinking about this audience of sort of municipalities are really trying to quantify what the value of resiliency is and what the cost of lost load is to you. Everybody has some cost of lost load, and the value of that lost load might vary between load types, right? And so that's an example where you might really want to keep your HVAC system running, but you don't care so much about your computers, or you really want to keep your servers running, but lighting and things like that you can keep off. So thinking about how you're evaluating the cost of losing those loads. Another thing to consider are regulatory barriers. Where are you connecting to the utility and where are you going to disconnect from the utility in the event of a sort of transitioning to an islanded state. What are the customization, sort of what level of customization is required for your solution? And then finally, the more complex you make your system, the more expensive it'll be, not just to install it, but also to operate it. The more custom that control logic is, you need to have trained personnel that can sort of address problems as they arise and respond to different scenarios. So those are just a couple points, and happy to take more questions later on. But that is the end of my slide deck.
Great. Okay. So thank you, Spencer. That's like the big overview story. Kelly has a handful of examples, or at least one that she's going to share as part of this. My instinct is to go listen to Kelly and how Revision does some of these solar and storage um, uh, uh, installations. And then let's have a discussion amongst Spencer and Kelly about what this means for the use cases you all might be imagining. So let's dive right in. Kelly, if you are up for it, I'll give you the floor and you want to jump in with your slides and let's hear a little bit about some of this experience or vision in doing this work.
Absolutely. Thank you, David. Give me just a moment. Hopefully my screen will share. All right. Are you all able to see my screen?
Yeah, it looks great.
Wonderful. So just a quick introduction for anyone who is not familiar with Revision Energy. We are a renewable energy developer based out of South Portland. And what we specialize in is the installation and operation of renewable energy equipment. We work with both residential and commercial customers. In our tenure, we've completed over 19,000 renewable energy projects for customers. And my role specifically, as David mentioned, is focused on commercial energy storage. So I'm going to spend a lot of time there today, but if anyone has questions in the future about residential solar and battery storage, our team is more than happy to assist with those questions. So diving in, this is a catalog of main projects that Revision has completed over the years. And the reason I'm putting this slide up is just because I wanted to showcase that there's not really a one size fits all when we're talking about these kinds of projects. And Spencer hinted at that. There's scales of size and complexity that come into these projects depending on what your use case is and what you need. And so one of the first things that I always talk to customers about, especially if they're coming to me saying, I really want renewable energy, solar and battery storage to be my backup resource. Um, Starting with just a quick education, what does that mean? Because solar is not like other backup resources. It doesn't sit idle waiting to be used. Once those panels are on the roof, it's generating electricity whenever the sun is out. And so your system is usually interconnected to the grid to make sure that any extra electricity can be either used on site or sent back to the grid and credited to you on your account. When we add the battery, now you have the ability to store that excess solar generation and dispatch that power for when it's going to be most valuable for you and your facility. This creates a lot of potential and a lot of opportunity to use that power. But the thing that I think a lot of folks need to keep in mind is that you have to have a specific use case in mind if you want the system to work well. Yes, batteries have the ability to control load while it's on grid. Yes, they can also provide backup power, but it can't do all of that well um, if you are not prioritizing one use case or the other. And so when I have customers ask about backup power, the first thing I say is, what does that mean to you? Give me an example of what does an emergency outage situation look like? Do you need an hour of backup time? Do you need several days worth of backup? What kind of loads are you trying to power? This is all really critical to determining whether or not renewable energy is going to be able to meet those goals. Um, and every case is different. So, for example, housing facilities or multifamily housing might have the need of making sure that residents can get to a safe place and to ride out that storm with temperature controls and kitchen equipment, things to stay comfortable for a couple hours until the storm subsides. Other facilities might have safety loads or critical equipment that can't afford to have downtime. These are very different use cases and profiles that would help determine whether or not renewables would be the best fit for you as a backup resource. Um, Sometimes what we advise customers is it's okay to use your renewables as a backup resource, but just keep in mind that whatever power you reserve, if you're only reserving that for backup power, you might be able to get several hours of support from that system until that system has completely used up its energy, at which point that system now needs to recharge. So, depending on time of day, if the sun is not out, you might have some downtime between when your system recharges and when you're going to be repowered. And so, how does that affect your outage plans? Making sure you have those things in mind to know whether or not you need a secondary resource, a generation resource like another generator or some other form of fuel that can help to provide consistent power throughout the duration of your outage. So when you're talking to a renewable energy expert, one of the first things I always advise is just have a clear goal in mind. What is most important to you if you're going to invest in solar and battery storage? Do you have operational concerns that are top priority and cost doesn't matter as much as long as you get the safety features that you need for your operation? Or is it that you're investing in this as a backup resource because it does have an effect on your operations, but ultimately you need that system to have a financial return? Designing a system really has some give and take, and there's a balance to be had. The other thing I advise customers is make sure that you're prepared to present as much information as you can about your facility because you want to tailor the system to your needs. Most of the customers we work with at Revision have existing facilities. So you have some load history or electric use that we look at together to say, how much electricity are you using at your facility? Or let's take a look at the loads that you are supporting within your service panel to know what's critical to you to have backed up versus what you're okay with turning off in the case of an outage. All of that plays into the sizing of the system and ultimately how much you spend on that system. And then, of course, just being strategic. It's not always cost effective to just max out your roof space with panels. If you don't need that much electricity, you don't have to fill up your entire roof with panels. Get the system that you need. You'll save so much money in terms of your investment and get a higher return. One use case that I did want to highlight. So this is a recent project, not in Maine, but outside the city of Boston. This facility is called the Kenzie at Bartlett Station. And this was a project that, so the Kenzie at Bartlett Station is a preservation of affordable housing project, providing 50 units of supportive, affordable housing for older adults. It's the first all-electric building over 4 stories to have an emergency battery storage system in the city of Boston. This is a really cool accomplishment that Revision was very proud to be a part of. The preservation of affordable housing was the developer of the project, working with the Dream Collaborative as their architecture firm to design this facility, and partnered with Revision Energy as the solar and battery storage installer for the project. The system, the PV and the battery system, were designed to help offset the costs of having an all-electric facility. So we specifically sized it to try and reduce electricity spend. And as designed, it's generally going to account for about half of the building's energy load. Now, it also serves as a backup resource. And so what they designed was, instead of trying to back up the entire facility, the system is intended to power critical safety features such as stairwell lighting and ensuring that elevators can safely get to the next floor so that it can deliver residents in a way that they can get out of the building or go to the community room where the community has set up emergency power, centralize the emergency backup to that community room, which will allow the residents to gather in a safe space, to communicate with the building administration on what's happening, as well as doing things like charging loads, staying warm, and refrigerating medication. So this is one of those considerations where more is not always better. It would have been very expensive to install a large PV and battery storage system to completely back up the loads for this facility. But as it is, the facility recognized that having this system has financial benefits that they put as the priority first, with a secondary use case that has the safety benefits for the community and residents. And because of limiting the scope of how much backup power they needed, they were able to invest in a more cost-effective system that stayed in line with the overall goals, the net energy goals of the project. I just wanted to conclude with a high-level snapshot just to make sure that we reiterate, I do think solar and battery storage are a great investment, whether you're a homeowner, a business, a municipal entity. If you have electric load, typically this is something where you're going to see a benefit. Now, if you're thinking of this for emergency backup, just take into consideration some of the key benefits and drawbacks of using this as a backup resource. One, and I think what attracts most people to these resources is the fact that it can charge from a renewable resource. People like the attraction that you can charge from the sun as opposed to filling your tank with propane or diesel. Um, that definitely has a tangible benefit in mitigating recharging costs, especially if you already have the PV on site to power your facility. And it is available to use on grid. So it's not a resource that just has to sit there year round waiting for the next outage. You can use it throughout the year to create a tangible benefit for your facility. Right now, there are still tax incentives, and in the state of Maine, there are grants that are associated to investing in these systems, which helps to offset the upfront cost for these. Now, depending on what type of entity you are, the incentive opportunities will vary. So that's where you could consult with your renewable energy developer or project manager to help identify what those opportunities might be. It does have a slightly faster switchover rate in an outage compared to a diesel or propane generator because it doesn't have ramp time the same way that a generator might. Now, the reason this is important to call out is that if you are looking to pair this with another generating resource like a diesel generator or a propane generator, usually what the order of operations we've seen customers do is that they put their PV and their battery system as the first line of defense in the case of an outage for that faster switchover and the fact that those systems are usually already on. In that case, the power from the battery can be used until it is depleted. And if you're using it because you're on grid, you might have ample energy stored or you may have a minimal amount of energy stored. That's where the secondary resource, like a diesel or propane generator, could kick in once that battery is depleted to continue powering the facility so that you don't lose power during that time and gives the battery time to recharge while that other resource is in place. So more in line with that microgrid configuration that we were talking about. But some of the drawbacks, so just to be aware of, if you're investing in these systems or if you have an existing system on site, it is very likely it is not enabled to work while the grid is down. And that's something to keep in mind because you do have to specifically ask for this. There's extra equipment and software that's involved to enabling these resources to be used in the case of an outage. And that is for the safety of electrical workers and making sure that we're not feeding electricity back into a grid that is down. That could be very dangerous. Enabling this backup power can add somewhere between 15 to 30% to your install cost of your project. So it is not inexpensive. And that's where having that clear goal in mind will help you to justify whether this added cost is worth the investment. And of course, we talked about downtime for recharging. So just being aware that if you are using renewables as your only backup resource, you may experience some downtime if you've depleted the battery ahead of when the sun can recharge the PV and therefore the battery. So hopefully this was a good snapshot for everyone. I'm more than happy to answer questions either in the webinar or as follow-up. But let me cancel out of my screen and hand it back to you, David.
Thanks, Kelly. Great. Love it. Okay, so some specific examples from revision, the overview from Spencer, and then all of you came to this call for some reason, like something piqued your interest about backup and microgrids. So this is the time where you get to ask some questions or have some conversations with Spencer, Kelly, or others. So feel free to drop a question in the chat. Feel free to raise your hand with the Zoom or make some signal so I know you're trying to talk. But what questions do you have for Spencer and Kelly? What's the use case you're imagining? What's the challenges you're looking at right now? The floor is open for questions and comments about these challenges and these opportunities. What do folks wonder about? Don't be shy. We're a friendly crowd. Yeah, Michael.
Yeah, are most of the systems you see going in commercial or private?
Private meaning like household?
Household versus commercial.
Yeah.
And I'm thinking PV with battery backup specifically.
Yeah. Kelly, over to you for that one, probably.
So let me see if well, to give you revisions perspective. So we've installed over 19,000 projects. Over 1,000 of those are commercial. Um, there's definitely more, let's just say it's not as quick to install a commercial system as it is for a residence. So we do see that solar and batteries are very popular with homeowners, especially now as we're seeing more an increase to outages due to weather related events in our northern New England area. Um, Commercial, I would say it's becoming more and more popular to add a battery to your solar array. We've been installing commercial systems in Maine for years. We have over 650 installed commercial projects in Maine across a wide variety of customer types. And I'd say only recently, though, have batteries really come into play. And that is because the state has put a lot of effort into incentivizing these systems. So that financial investment that used to be a huge hindrance is now being offset by incentives that are offered through Efficiency Main Trust. There's also the utilities are trying to incentivize control over how you use load. So that's also helping to offset the investment in batteries. Um, I can't give you percentages, Michael, but I'm hoping that helped answer some of your question.
Yeah, no, that was very helpful. And
Yeah.
my follow-up question, you mentioned that there are incentives, efficiency main. What specifically do they have for battery systems? I thought the federal tax credit went away at the end of last year, and that was probably the biggest tax incentive. What else is left out there?
Absolutely. So the good news for batteries is that the investment tax credit did not, or the changes to the investment tax credit did not carry over to the battery storage solutions. They are one of the only technologies that was not affected by the One Big Beautiful Bill Act. So that tax credit is still in effect for battery storage systems through 2032. Um, what is changing is that, yes, the PV tax credit is sunsetting. Um, Developers like Revision Energy have maintained some equipment that is safe harbored under the old rules that we can still claim the tax credit for certain project types. Um, but battery storage systems are still eligible. Now, the incentives. So, Efficiency Main Trust maintains a battery management program, and this is specifically to help curtail grid congestion. It's for anyone who has specifically batteries on site. You can enroll in this program to participate and help control and lower load during peak congestion times and earn revenue for that. So they'll pay you annually for depending on how much load you can lower at certain times of year. And so this can be a huge benefit to those who have batteries because most of the time you don't even notice that this is happening in the background. It's being controlled by software, the battery is dispatching, and you earn a check at the end of the year. So there are programs like that. In certain cases, there are other grant type programs, although we are seeing less of those under some of the changes of federal grant eligibility. But in certain cases, there may be niche grants or other incentives that your system could be eligible for just based on the customer, your entity type or your location.
Thanks, Kelly. Really helpful. And we know that demand management is a key piece that Maine's trying to manage in other
Yes,
states as well. So likely going forward, we'll see demand management programs emerge, right? Um,
absolutely.
question from David. Go ahead, David.
Yes, I was wondering
Hi,
if you,
thanks.
Oh,
Enjoyed it very
sorry,
much.
David
Oh,
Lunsbury,
was there more
and
than
then
one
David
David?
Jordan. Other David.
Okay,
Hang on one
okay.
second, David Jordan. David Lunsbury, and then
Can't have
David Jordan.
you,
Sorry
you
about
can't
that.
have
I
too
should
two
have
many
been more
Daves,
Daves.
two
specific.
Daves. Yes, thank you. I was wondering if you had examples of any um, multi-tenant campuses or islands where you've got multiple organizations or enterprises that actually share the microgrid, and give us some idea of how what the biggest one was, or what some of the factors in that are.
So Spencer or Kelly, if you've seen any of these projects where you've got more than one like tenant or owner and you're managing that.
Yeah,
Can you share?
I can give an example first and then hand it over to Kelly. I was the engineer on the repowering of the power system out on Matinicus, which actually doesn't technically meet the definition of a microgrid because it's not connected to the bulk electric system, but a lot of the same sort of design and engineering principles hold for that system. Um, the sort of geographic reach and protection and control was sort of more extensive than what I've seen elsewhere because it has a distribution network of overhead wires and poles. There's sort of utility grade relays in that system. A lot of custom logic for dispatch, but the actual system is not actually that large. A medium-sized office building probably uses as much power as the whole island. Maybe not on the hottest summer days when all the summer residents are there, but that's the largest system that I've worked on. But for that sort of uh, yeah would be classified or something similar to a microgrid.
Thanks, Spencer. David Jordan, over to you now.
Thanks. Very interesting, guys. I appreciate it. I was just wondering if you could speak to the providers of these battery systems. I have a Tesla Powerwall. When I got that, I think that was sort of the only game in town. I was wondering if if there's some emerging new capabilities. Do you kind of build these things custom, or what are you seeing coming along? Thank you. Whoever wants to answer that, go ahead.
Yeah, Kelly, Spencer, where
You want Spencer? I can take the first pass
Sure.
at this.
Yeah, yeah. But I guess it depends on the scale. And probably the batteries themselves are more of a commodity than the controls and protection that are required for the system. And so if you have just sort of that limited backup use case, you have a critical loads panel, a single PV battery, perhaps even a generator, but it's all integrated into one box. Kelly can probably speak to some of the providers for that. But if you're talking about a larger system, with multiple facilities, multiple generators that are operating at once, um, the protection and controls piece is largely custom. There are some vendors out there, but I don't think that there's so I've worked with a couple of them. New Sun Road is one that I've been working with most recently. But it is still a pretty custom application that requires a lot of hands-on time for each individual project.
So, long story short is that yes, there are a good number of vendors who are manufacturing both battery systems and controls. Some more experienced than others. And so we are technology agnostic at Revision. And so we spend a lot of time trying to vet companies that not only manufacture the products and the sizes that we need, but also have longevity. And I guess the term you could call it is bankability. Who's going to be there in 20 years to service that system once it's online? And so Tesla is one whom we have worked with for many years. On the residential scale, we are also now working with Franklin Whole Home, as well as SolarEdge has their own battery system. So those are some residential options we work with. And then on the commercial side, there are many vendors. The ones that we are currently choosing to work with are companies such as Socomec, Tesla. There's Solarc is another reputable company, but we really focus on companies that not only provide quality of product but also a level of customer service as well. Because ultimately, if something happens with that system, you need to be able to call someone and make sure you can get that issue resolved. And so those are some of the ones that we've seen provide that level of support.
How
I
about
hope
the capacities? Are we, there's rumors that's improving dramatically in the not too distant future. Can you say anything about that?
capacities as in
I mean
duration of how long.
capacity based to to cost, obviously. Yeah, for
Yeah.
sure.
Hmm.
Um, so things shifted a bit. Costs were coming down on batteries. With the new ITC eligibility rules, there is a push to have more domestic components into your system in order to qualify for ITC. And so in the coming years, I think one of the things you're going to see is systems that are um, let's say cheaper in cost and manufactured in places other than the US or Europe. And there's going to be more systems now that are going to be domestically produced that have a slightly higher price tag but are eligible for the ITC. And so there's kind of, I'd say, going to be two paths that you see of systems that are either inexpensive on their own or might have a slightly higher price tag, but then qualify for that the ITC reduction, that 30%. So far, what I've seen is that ITC still does make a difference on system cost. So that's just something to be aware of is depending on your tax status, if you are requiring that tax incentive to help offset your upfront cost of your system, making sure that you are carefully selecting the hardware that goes into your project.
Yeah. And I would just add that, I think depending on the scale of your system, there's more decoupling between the sort of raw dollar per kilowatt hour cost of storage, sort of coming off the factory versus the system that an end user is actually going to purchase. And a lot of that's just because of all of sort of the balance of system equipment, design time, engineering time, things like that. So, if sort of the dollar per kilowatt hour of storage has dropped in half over the last, 5 years, that doesn't necessarily mean that a storage system, the cost of a storage system has dropped in half. If that makes sense.
Thanks, Spencer. Yeah, Kelly. Any other questions we have for Kelly or Spencer? And feel free to drop a question in the chat if that's more comfortable. Um, what's a dilemma you're working on? What's something you're trying to solve? And maybe Spencer and Kelly could help you think through the application you have. Back to you, David Lunsbury.
Yeah.
It looks like Randy's also raised his hand, not to cut
Oh,
you off,
sure.
David, but
Oh,
just to give everyone a chance to ask their
I'll certainly
questions.
defer.
great.
Yeah,
Randy,
thank
you
you.
first, and then back to
Yeah,
David.
thank
Sorry
you.
about
Yeah.
that.
I'm a forester by trade, and foresters are always looking for markets. And I live up here in northern Maine. We have a large wood basket that is pretty much has no low grade markets for. And I thought microgrids was more for like, creating electricity and the solar. We have solar arrays up here, and we're working on battery storage. But my hope was that we could create some electricity through small biomass boilers. Does anybody have any experience with uh, biomass, wood, electricity? We had two large biomass generating plants, and they closed. They were subsidized, and they closed. And so, yeah. Any thoughts on that?
Thanks, Randy. I don't know. Spencer, do you have anything on biomass you want to share and how this might fit into a generation story here?
Yeah, I haven't seen new biomass plants going in recently, but I do know that one, in the context of microgrids, one use case for something like a biomass plant is combined heat and power. So especially if you have a sort of geographically dense campus where you can distribute heat from a central source. And even better if you have the infrastructure already in the ground for steam tunnels and things like that. Being able to generate electricity from the combustion, and then all the waste heat isn't actually wasted. It goes to heating buildings. That's a use case that is I think most common on college campuses. Or other places where you have sort of that sort of dense heating requirement.
Thanks, Spencer. Okay. David, back to you.
Yeah, Kennebunk is one of those towns that has a municipal power and light system. And I guess the best way to put it is while it's an independent entity, the town is consulted on on where to go. Is there any advice you would give to the people from the town who provide input to the local power and light about what they should anticipate or directions we might want to suggest to them?
Mm. In the context of backup and microgrids and that
Yeah,
kind of context,
yeah,
David?
microgrid, local resilience, things like that.
Got it. Okay. Spencer, any thoughts on for like a relatively small utility like Kennybunk?
Sure. I mean, I guess I think it would be, sort of Kelly touched on it and it was in my slides as well, is just clearly identifying the objectives. If it's to save money, resources that Kennebunk might install, depending on sort of what your exposure to wholesale market prices is, you might be installing resources that could be part of a microgrid, primarily to save costs while in a grid connected mode. Um, if there are specific centers that are high priority for keeping energized during outages, um, schools or libraries or things like that, that could be something that could be discussed amongst residents. But I think defining the objectives is definitely the first step.
I agree with Spencer. I think depending on where the key constraints are. So, for example, I can't name names for confidentiality reasons, but some utilities that we've spoken to have chosen to purchase the renewables directly and the generators directly in order to back up their own facilities to ensure that they can provide continuous power. Someone mentioned island communities. That's a very popular use case in island communities. The utility is the one who actually purchases the assets and then controls them. But if your primary issue, for example, is that you have downed power lines and individual sections of town have outages and fits and spurts that you can't get to service, there I've seen other utilities who incentivize setting up emergency shelters, and they create a pool of money to incentivize those community facilities that would volunteer to install at those sites and do a community emergency shelter. Um, so I think Spencer's point is very valid, but I just wanted to follow up with a few examples, hopefully spur some ideas for you.
Yeah. Thanks both. Okay, I think we're getting towards the end here. Any last thing that folks want to slip in one more question before we finish up? Okay, great. Well, I want to thank Kelly and Spencer in particular for investing some time with us today. As Karina mentioned, this call is part of a broader initiative that SMPDC is doing. Before we finish up, Karina, do you want to say anything else about next steps on SMPDC's initiative on this Southern Maine energy resiliency plan?
Yeah, thanks so much. Those were really interesting presentations and so much insight shared. I just put in the chat my contact information as well as the link to our webpage that has all of the resources and materials for our energy resilience plan. We are in the final stages of revising our draft for that plan and plan to release it publicly in the next month or so. So we'll be doing a big outreach push about that, but it will also be posting it on that webpage. As part of this project, we did do a sort of in-depth deep dive into the feasibility of microgrids at critical facilities here in Southern Maine and York County, and developed sort of a memo that outlines these steps that Kelly and Spencer really alluded to today about how to evaluate what option works best for your facility. I put the link to that in there as well, or you can find it on the webpage, but that's our microgrid feasibility analysis memo. So if you're interested in getting more into the nitty-gritty details, feel free to take a look. But that's it for me. I'll pass it back to you, David, to wrap up.
Great. So stay tuned with SMPDC on other things that'll come out of this final plan when it's ready later this month. And thanks everyone for coming out and having a conversation with us today. Really appreciate it. And thanks for the very good questions. And that's it. We're done. Take care,
All right.
everyone. Have a great rest of your
Thanks,
day.
everyone.